Okay, so morning, Master Mason. Note. Morning, Briff. Figured we'd do one up here today. So last night I've been smashing out a few math teachers, Stanford. We're talking heavy duty stuff in theoretical mathematics, theoretical physics, and things like that. Now, a lot of times I wanted to put those guys up there so you had a reference of both the material, a reference material to go check out some of those terms if you'd like to, because remember, there's a lot going on in there, a bunch of subparts that rely on different numbers because this is that real world thing. Early in the beginning of this video, he's talking about this triangle. It's got Higgs on there, it's got Einstein on here, it's got Heisenberg or Young's-Meals, excuse me. I think it's Young's-Meals, Heisenberg, and Newton or Einstein on here on this triangle of stability. And I just kind of look at that and I say, well, that's obviously Rich, Veer, and myself. If it was just me in the stone mill, it would be me and me plus F plus here Newton, or somebody good in engineering and economics for the stone mill. So just me being a business, that's the correct answer. That's Y or X. Then there's any advent where I added something to this. So we're getting into some time paradoxes, but let's just assume that that works the same way too. What I'm doing here now, what I was doing 10 seconds ago, is now I'm integrating mathematics. And you might not ever know that about me from history, or for the net force or objects in motion that remain in motion. Given its spin, what's it look like, its mass and charm? Neither do planets. They don't work that way. They do what's in front of them like that. So I do want to quickly, I do like the mathematicians in here, but often I miss that they don't provide a good N1/2. And often, sometimes in these lectures and in the back rooms of Masons and things like that, you'll often hear some things like, does this person really understand what they're talking about? So this is important. Now, very academic in the fact that you can recall some path from a mathematician back in the day, or you've watched this college thesis, but short of you videotaping it, did you write down every part of every equation in there? And therefore understand that this little graph on 3 red, 1 blue with a little rope right here is your neck sliding through the head of the rabbit trap. They're all rabbit traps. Here's a box, and hopefully I use that saw program, because he'll, in the first few minutes of this mathematicians, the singularity or the hole or the portal is what the guy calls it, is that working force bar is correlatable in some way to the stone mill. All the symbols say wave function, all of them say change and sigma sum. Well, a stone mill is sigma sum. The output on the tread is sigma sum. In a sense, you have Jordan plus Newton, and you have Jordan plus Newton and Einstein in the corner of this. All of them are confined by this triple point that is me, something that somebody else saw. And a lot of times, if I can, I want to think they understand the problem is this product rule. And yet sometimes I feel that they fall short, or they understand this number and take malevolent advantage of the situation. You got to clock in. You can't have an output, especially when the result is a classroom, and then there are working joules of how that classroom works, why tests are this symbol, why midterms are this symbol, and they represent everything in Schrödinger at your place in this equation to what you're supposed to learn as an overviewer to a student's perspective, because that would determine grade. Here's this physical event in front of me. It doesn't correlate to the terms. I'm on a syllabus that puts you on a line of when you're supposed to recognize those things and not, because otherwise I don't care. Those things don't really apply outside of here given the syllabus and what gravity applies this term to be. So everything that you can provide on the board, let's call it Leonard there with the black holes, let's call it the Stanford teacher with the force bars, let's call it a behavioral scientist and psychologist dealing with a whiteboard at Stanford. I have multiple of these models. I provided them for you. And what often you find is you're still this person in the tread line that's thermal and rock. Why would there be a difference? Why would there be a difference comparatively to all the x's in how they graph something off in this z function? Close to 0, very close to 1. A lot of times you take that in consideration on the low end and the high end for -1 calc and +1 calc. There's an entire matrix. This one determines this first part, but there might be another group over there. There might be another stone mill. It might be the combination of all the stone mill's numbers. There's no real walls that define that. And as a business, you have to look at that and say competition, you have to say nation, things that we share in common for this equally as areas over New York City to California. And this is where you see a lot of this statistic analysis type of or data analysis processors as they present themselves on the board. And often you'll see this representation by a census person or somebody who's highly refined in a very specific subset of what those irrational combinations loosely form into in that position. Because the position is the position, it's not math. And then if they don't know how to do the job, there's an 83 on that. And regardless of how much wave function systems you teach that, it's not going to break their free will to understand, if I don't calc this and understand the results of that, I never will. And it's going to continue in motion like that until something hits it. And a lot of times in the universe that works that way. Teachers and salties and everybody, myself included, often forget that in nature it'll have the same effect. You'll be walking in the woods and you'll lose something, it just won't be there. You didn't pick it up. Comparatively to that type of bark that was real good and you had it in your army survivaling training and you saw it, you needed it, you made the recognition XY to put that function to sleep, to no longer have that stress banging around in your frontal lobe about the standard in the situation. It will. We're just trying to touch on the subject and keep moving. So in here, it's like I said, you got to check those mathematicians. There's nothing wrong with that, and by gravity standard, it's probably fine. But how useful is all of that course, that 2-hour course on this type of thing? You'll see symbols in there, not have a damn clue what any of them represent. You'll be watching a guy fill out a process of a piece of paper, much like 3 brown, 1 blue. At the end of the day, that's all I do in the stone mill. It's A, B, C, and green. And then we're going to come over here, make a little graph. I'm going to draw this down, put a little box in it, say that that's proper torch maintenance in the morning. And that graphs the serviceability on the depressions or crests for success in that stone mill over an average. And that's just the write-out. Much like that professor on those chalkboards, I've seen lots of managers whiteboard training the entire issue, but generally time is the problem. In the stone mill, often you walk in there, you'll see weeks and months worth of, or certainly the week's progress report. This is the output. This is the cut coefficients for the 5-footers with the pallet counts and the block numbers that are up there. None of which means anything to you as an apprentice. But at the same time, then it comes down situationally later, X's and O's, 1s and 0s between this palette and those counts and that graph and AX, BX, CX systems that really do the same damn thing, don't they? I'm not bagging on that, I'm bagging on some of the old schoolers. Hey, step it up a little bit. A lot of mathematicians fucking around out there on the floor and you don't necessarily understand this. On the back end of that, math teachers, you have everything to do in the same regards to this application. Quit fucking around. What you need is active battle plans. For them to say that this abruptly long sequence of reciprocating terms on the board is actually going to be practical in the form in which they mathematically should be able to use that at any point in time, it certainly falls short. I don't use them like that. I might reverse engineer it backwards in an N1/2 sequence, but that still relies me to stand in that spot and do that job. If it's not thermaling, I could easily say it's rock facing, but they are not the same thing. And if you get your constants wrong on that, you say black holes are black holes and not neutron star material with a physical shift differential, well, you're going to have all kinds of quantum objects and you're going to be in outer space. I'm going to make sure of it. I'll put you up there. Horns, halo, whatever, wings.